Hello and welcome to SudoKanard. We're here to solve this region line sums Sudoku by Philip Newman from Sudoku Mahabharat. And this was quite a difficult puzzle. I don't think it was as difficult as Diagonal Skyscrapers, but it was still difficult. And I solved it during the contest and I missed an important step which caused me to bifurcate in an unhealthy manner and a necessary manner. And I hope I will be able to find the smooth solving path because there is a definite solving path and very elegant at that. So first I'll explain the rule. You have lines and lines will be divided in segments inside each region. So those three digits are in this region, those two digits are in this region, this single digit is in this region, and those three digits are in this region, and all segments have the same sum. So those three digits sum to this digit, those two digits sum to this digit, and those three digits sum to this digit as well. And those three digits have the same sum as those two, etc. So the place to start is definitely here. The sum of those three digits will be at least 9, and at most 9 because it is the same as this. And when the minimum and the maximum are equal, they are the only possible value. And 9 is also the sum of those two digits without using 2, 3, or 4, so they must be 1 and 8. And 9 must also be the sum of those three digits without using the 4. They can still be 1, 2, 6 or 1, 3, 5. But if I recall correctly, this will be disambiguated pretty late in the solve. This 9 now, and this is the step that I remember that I missed during my solve. This 9 must appear somewhere in those cells. And it can't be here because if 9 were in those cells, they would sum to at least 10, and this digit can't sum to at least 10. Likewise, 9 can't be somewhere here because the sum here would be way too much for this cell. So 9 is excluded for all those cells, and 9 can be placed here. So this is a nice step and very important in that. Something else is that this digit is at most 8, and with the 4 here, at least 7. The minimum value here is 1 and 2, which makes this 7, but it could also be 8 if those digits are 1 and 3, which means that there is a 1 here. Okay, which means that the minimum value here is a 2. And now let's look at this. Now knowing that there's a 1 here, and a 2 or 3, and 4 there, the minimum value here is 2 and 5, which means that the minimum value here is 7, but you can see that this is also the maximum value. So that this is 7, and those are 2 and 5. We can remove 2 from those cells. And here we get 6, 7, 8. That's not 7, that's not 8. And actually 7 and 8 would turn the sum to 16 or 18, and nothing would work here. Only 6 works here with a 9 there, and this is 8 and this is 7. Alright, and now the sum of those three digits is 8, like this is 1, this is 8. with those 8s. There is an 8 in here. I think that 8 here would be too much. Yes, the sum here would be at least 17, which would force those to be 8 and 9, and that's impossible. So 8 doesn't go here, it goes there. There will be an 8 somewhere here, but those 3 digits sum to 8, so those 2 can't contain an 8, so 8 goes there. And by the rules of Sudoku, 8 goes there as well. Which is interesting because 8 is much higher than that. We can see this 8 is 4 more than that, so this digit must be 4 more than that. And this digit is at least 3, so this is at least 7, so this is 7 or 9, and correspond. Oh, but 9 here would make a sum of 13, and force this to be a 5, and 5 is not available. So that this is 3, this is 7, and this 3. Places 1 here and a 3 there. Now the minimum value for those two is 4 and 5, which is also the maximum. Places a 5 here, a 9 there. 3 here, 3 there. We can place 3 on this row. Those are 5 and 6. Those are 7 and 9, but there's a 9 here. Those are 4, 6, and those 3 digits must sum to 15, so that this is 5. 3 goes there. 7 goes there. Those 2 digits sum to 11, so those 3 must sum to 11. That's 1. This is 2. This is 1. This is 2. And now 9. Those 3 digits can't be 1, 3, 5. They must be 1, 2, and 6. That's not 1. That's not 6. Here we need, well, we need 8 there. 9 goes there, and this is 5. So the sum here is 13, which means that those 2 digits sum to 10. They can only be 6 and 4. This is 5, 5. I said this is 4, this is 5. 5 here goes there. And by the way, this is 4, this is 6. Down there we need 2, 7, and 9, so that's 7 here, 9 there, 2 here. That's not a 2. Up there we need, oh, by the way, this could have been resolved a while ago. 8 is the sum of those 2 digits without using 6 or 7. There must be 3 and 5. So that this is 1. This here is 4. This row needs 1, 2, and 4, so this is 2. And 1 and 4 are not resolved yet, but it shouldn't last long. Here, I need 6 and 9. Those 3 digits sum to 10 without using any of those digits, so they must be 7 and 3. Those 3 digits must sum to 8. So there must be 1, 2, and 5, and this is 4, and this is 1, and this is 2, this is 6, this is 1, this is 5, this is 2. Here we need 5 and 6. This is 9, this is 6. Here we need 2 and 9, so 2 and 9. Here we need 4 and 3. Here we need 7 and 3. Here we need 6 and 8. That's a 4. That's a 1. And no fireworks, because this is the competition interface, which does not tell you if you are correct or not. And I think that this is correct. And as you can see, this is a really neat solving path. I'm really glad that I finally found it, even though I took quite a straight path during the contest. Thanks for watching this video. See you soon on SudoKanard.